Okay, so we're going to talk today about complex power, which is a phasor. This is the real thing that we're going to talk about. There's a few other topics, but they're really part of this complex phasor. The next is the real power. And that's just a number, a real number, unlike complex power, which is a complex number. We'll talk about reactive power, which is another real number. And then last, we'll talk about apparent power, which you might remember we introduced last class, which is, again, a real number. So last time, we talked about phasors, which are strictly for the sinusoidal steady state. So it's only for a form of voltage equals some sort of maximum voltage times cosine of omega t plus the angle associated with the voltage. Just as a reminder, we're going to write that as this complex number, this phasor, which is equal to this maximum voltage at the angle. Average power. Which we generally abbreviate just as capital P, we've already said is equal to the real part of the voltage phasor times the current phasor, complex conjugate. That complex conjugate flips the sign, so when you multiply these phasors, the angles will be angle of V minus angle of I. And we said this is going to be equal to 0 for capacitors and inductors, and it's going to be greater than 0 for resistors. And we measured in watts, and it's a scalar number. We said there's actually two ways. We did talk about a second way that we could measure this. We said it's also equal to just the voltage phasor measured in RMS, dotted with the current phasor measured in RMS. Either one. Last class, we also talked about this new thing called apparent power. And we gave it the number, the variable S. Bobby, can you tell me? I'll tell you how you calculate it. So notice this is not phasors. These are just magnitudes. Bobby, can you tell me what the units are?
Volt amps.
Yeah, that's it. Volt amps. And they make it a different unit just to really make it clear that this is not the same thing as average power. And this is also a scalar. And the only other thing we covered was that V RMS is equal to V maximum over the square root of 2, which could be a scalar, or it could be a, as I've drawn it as V maximum here, this would be a scalar quantity. Of course, if instead of V maximum, we wrote it as this phasor, it would be a phasor quantity. And similarly, we have this I RMS, which is just equal to whatever the maximum current is over the square root of 2, also a scalar.